All right, I'm gonna go ahead and get started. It's 1:45. So first talk after lunch, everybody's probably tired and digesting. I think this is probably the simplest, easiest talk that you're gonna attend here at the conference. So it's a good one. It's a good one for right now while we're all feeling a little tired and a little relaxed after lunch. My name's Dave Godlove. I work at CIQ, and I came there from the National Institutes of Health, the NIH, a while back. CIQ, if you're not familiar, we're the company that provides support for Rocky Linux. We also provide support for Werewolf and Aptainer, and we develop a cluster management tool called Fuzzball, which is also a container orchestration tool. So we do a lot of different things. But today I'm going to be primarily focused on talking about Aptainer. And as I mentioned, this is going to be a pretty simple talk. It's actually so simple that I actually wondered if I should even give it. But the thing is, this is going to be work that I worked on way back when I was at the NIH. And I've talked to a lot of people about it since then, and every time I do, it seems like somebody gets kind of excited about it. And so even though it's kind of a simple idea, I think it's worth just making sure that people know about it. Some of the good folks at NERSC yesterday gave a talk about containerizing user space within the cluster, and that was a really great talk and a really great idea. This is going to be a little bit different from that in that I'm not going to be showing you how to containerize an entire environment for the user. I'm just going to be talking about how to containerize individual applications and make that transparent to the end user. So that's the basic idea here. Okay, so here's where we're going today. It's only 10 minutes, so I don't even know why I'm showing you in this detail, but I'm going to talk about why should we install scientific software in containers. I'm going to talk about this simple method a little bit. We're going to cover this method and how it looks in practice, and I'm going to close up by just talking about some pros and some cons, okay? Once again, very simple. All right, why would you want to install scientific software in containers? Well, I think that at this point in time, most people kind of understand the pros of doing this. It's modular, it's reproducible, you can handle privileges really nicely, things like that. But the thing I'd like to focus on here is simplicity. So let's say you're a staff scientist working within an HPC environment like I used to be. You probably have users coming to you quite a lot and asking you to install new scientific software. Okay, so that can be a pain because scientific software can be, written however the scientist wants to write it. And so, what if you go to the GitHub page and the first thing it says is, all right, run an apt-get install, add a repo and then run an apt-get install, blah, blah, blah. You're like, okay, well, I can't do any of that. But with a container, you can. So it makes it much, much simpler for you as an administrator to just install this software on your user's behalf. However, there's a problem there, right? Because if you install your user's software within a container, now they have to know about containers in order to be able to use it. And let's be honest, if they already knew about how to use containers, they probably wouldn't be coming to you and asking you to install their software for them. They'd already have it handled. All right, so this is the point I just made. And a lot of times trying to run classes or educate your users on how to use containers or something, we want our scientists to remain scientists and not have to be computer scientists. We're trying to meet them and let them do what they need to do, right? All right, so I developed at the NIH. It's a simple method. I worked on this method at the NIH with some other folks. For the purposes of this talk, I put together a GitHub repo that you could go to and see all the details of it. It's called, so I'm Godlove D, and it's called Transparent Containerized Installations. It's kind of a mouthful. But there's a README file there, and there's an install script. And if you run the install script, it'll install within your system a transparent application and kind of show you how it works. As I said, this was developed at the NIH, and while I was there, so the NIH staff maintains, when I left, it was somewhere on the order of about 800 scientific applications for users. It's probably over 1,000 now. And when I left, something like 80% of the applications that were being installed using this method. So even though it's really simple, it scales really well, and you can handle really, really big environments this way, or really big software stacks. I thought, we were creating all this new art while we were doing this, and I said, why don't we go ahead and release all that into a GitHub repo? So there's this other GitHub repo where you can go and see all the definition files that we were developing. It hasn't been updated in a while since I left. I don't think anybody's really keeping it up to date, but it's still a good place to go to get ideas and starting points. So what's the method? So you start by saying, okay, whatever the software is that my user wants, I'm gonna either go find a container or I'm gonna build a container that's gonna install that software. So here we're just gonna say, okay, well I want Cowsay and Fortune and LOLCat installed on my system. So we're gonna go get the LOLCow container, right? That's the one we're gonna use. So first, pick a container. Second, you create a little wrapper script. And this is probably the most difficult part of this entire talk. And the idea behind this wrapper script is I'm gonna take user commands and I'm gonna translate those into Apptainer commands, all right? So basically I'm gonna figure out what was the user actually calling by querying $0 and stripping off the path. And that's really it. And then I'm gonna take that command and I'm gonna feed that here into an Apptainer command. All right, well, if the user's calling the wrapper script, then that doesn't really make any sense. But here's the magic. Step 3, you just make some symlinks, right? So I say, okay, I'm gonna symlink Cowsay and Fortune and LOLCat all to this same wrapper script. And then, whenever a user calls any one of these commands, if I go back here, that's what this CMD is gonna end up being within this wrapper script, and that's what's gonna end up being passed to Apptainer. So voila, your users don't even have to know that Linux containers exist and are even a thing. To them, they're just running these commands, they're executing on the system. You can set up your bind path environment variable to bind in their data directories on their behalf so that they can see their data. If you have GPUs that you want them to use, then you can set the --NV option here, or you can just set the environment variable. It's really very flexible and really easy, and the users don't even know what hit them. They're just using their software. So at the NIH, what we ended up doing is we would set up directory structures like this. So we would say, okay, well, wherever we're installing it, we're going to have the name of the application, the version, and then we're going to have bin, libexec, and source. And I suggest doing something like this because this lends itself really well to integrating with a module system, right? So now you can this new application that you just installed on behalf of the user, you can have them load it with lmod. You can put the bin directory on their path. They've got access to all these commands now, and they won't accidentally, execute the wrapper script or the container itself because they see it now and they want to run that. And then I suggest that if you create a new container just to keep everything together, you can put that in the source directory. So what are some of the advantages of using this approach? Well, one of the big advantages is once you do this once, if you have another user come to you and say, well, I need a different application installed, now installing a new application becomes as easy as copying that directory structure and renaming it a new application name and a new version, swapping out the container with a new one, and changing the symlinks. And now you've just installed new software, as simple as that. So it's really repurposable, and you can just keep on going. As I just explained, it works with modules. And then you get some advantages of containerizing your applications, really no matter how you do it. What are some disadvantages? One thing that a lot of people worry about with this is storage. So now your smallest applications are at least on the order of tens or maybe multiple, maybe even over 100 megabytes. So this does add up, but we're talking about like high gigabytes. Maybe if you've got a huge, really extensive software stack, maybe low terabytes, but like we're talking about like adding another user to the cluster basically. We're not talking about anything too crazy. You now also have a dependency on Apptainer. So anything that runs, you got to have Apptainer working now. And there are also some kind of pesky applications that don't lend themselves well to this. So if you're using like a suite of applications that all expect to share the same libraries, for instance, well, once they're containerized, each one of them needs access to its own libraries. You're not going to be able to share libraries very easily. Or if you have like an application that expects that it's going to run MPI commands on your behalf, or it's going to, call out to Slurm and try to schedule jobs and do things like that. Those are not necessarily, great candidates for this particular approach. You can get around those things in different ways. You can kind of hack around those issues, but it's suboptimal. All right, and so like I said, that is a very, very simple talk. So I'll say thank you, and if you have any questions, you can either ask them now or I can talk to you about it later. There's a question in the back. I don't know if you want to run the mic.
Hi, I'm Elijah with Oak Ridge National Lab. So you talked about the fact that if something uses MPI, then this application is not suitable for it. Is it that you explored the possibility of an application that uses MPI with it and you were running into trouble, or why? I'm curious, because this appears to be really interesting. Something that we could make use of, but the fact that it would now work with MPI is a limitation, so I'm just curious. Yeah.
Let me clarify. So it'll work with applications that run on MPI. That's fine. Where you end up having trouble is if you have, some applications try to be tricky and they say, okay, user, just give me some information and then I will construct for you an MPI exec command on your behalf. And then I will myself execute MPI exec, the name of the, whatever, and then and go ahead and do that. Those applications end up trying to outsmart themselves, I feel like, because then what you end up with is that MPI exec command, when you run it from inside of a container, it tries to use SSH or RSH or whatever to go out to the other nodes, and it tries to start things that are now outside of the container. And it's got no understanding of, oh, I was a containerized command and I'm supposed to, start things in a container. When I alluded to the fact that there are like hacky kinds of things you can do, you can replace the SSH command inside of the container with one that will issue a container, like an SSH and then an apptainer command. And then you have to play tricks with environment variables, and you kind of end up going down a rabbit hole. You can hack things around to make things work that way, but it's difficult and it's really kind of ugly. Does that make sense?
Yeah, it does. Thanks.
Cool.
I mean, maybe you could do your MPI in the wrapper script and have it run the containers rather than having it inside the container. Right, because there's like the share namespace option to apptainer to be able to run your separate containers together, and they become connected together with MPI.
Yeah, I mean that works if you have just an MPI enabled application, I think, inside the container. But once again, if you go into the container and then that application wants to run an MPI exec command, that's when you end up having trouble.
Right. Any other questions? Here we go.
Yeah, so for that you can, it also depends on the cluster, like whether it's Slurm or PVS, you can have PMX, the things hooked up from the host, right, and make it work inside the container. So that's like what we do with Shifter and Puma HPC.
It's still a separate issue, but that is a great point, is that you don't have to have an MPI implementation installed within your environment.
Right.
You can just compile Slurm or install Slurm, whatever, with PMI, PMIX support, and then you can issue the directives when you run your job to say, hey, it's an MPI job, go ahead and wire it up. Yeah. And that's a great way to do it, actually, because it's very, very flexible. you end up not having that problem where your external MPI environment has to match your internal MPI environment inside the container anymore. That's a great best practice.
So that falls apart with that falls apart with GPU and device machines where the MPI implementation is doing something special for like GPU aware MPI or something. So we worked at this at Sandia quite a lot. So there's something called Y for MPI, WI for MPI.
Yeah.
And it's strategies, and part of the MPI spec now standard has the ABI compatibility has come into play, and there's some tooling. So Y for MPI is one of them, and it's interesting because it enables you to have an MPI on the inside and an MPI on the outside, and then it stitches them together so that this works.
Yeah.
But
so I think Y for MPI also has applied, maybe been accepted to HPSF. Yeah, is that correct? Yeah, I'm pretty sure we heard a talk by them, and I got really excited about it, and I started asking some of the folks in the Aptainer, actually Cedric within the Aptainer community, to have a look at it and see if we could integrate it.
Yeah, it's a headache.
It is.
It's a
Yeah,
real
yeah.
headache.
All right, I'm running over time, I think.
It's scheduled at 2:05.
Oh my gosh. Okay, so I had more time than I thought. I only had 10 minutes.
Well, 10 minutes and plus probably a transition time, so yeah.
Okay.
Yeah,
Well, yeah, I don't want to, like, if you guys need another break,
No.
I don't want to dip into that, but I can continue to answer questions or have discussion.
Yeah, because we don't really want to start the next one in case someone comes over waiting for that time, but yeah. Any more discussion?
Yeah.
A different question. So have you worked on how you would map so imagine you're on a heterogeneous machine and you want your container to see, say, the GPUs underlying on the host OS. And so we've had some fits with like having to map in devices into the containers and that way the inside sees what there's like it's the illusion that the container can be truly containerized starts falling apart when you need kernel modules on the host side that do magic for the execution inside of the container.
Right. Yeah. I mean, so that's the basic problem is that when you run a container, you're taking the kernel on the host and you're pulling that into the container with you, and that's how you get the benefits of the performance that you get. But it also means that you pull in the kernel modules, and then you've got to match up the user space libraries to whatever the kernel module is and everything. That's kind of like the way that we've got the --NV option architected, is that it will check the version of your kernel module, and then it'll go out on the system and it'll go find all the libraries that are associated with that version and bind mount them in, along with, I think, devices, as you said. It's kind of hacky, and it's always been that way. I was one of the folks who originally worked on that implementation, so I can kind of say it's hacky, and I'm not insulting too many folks. But so the way that came about is that so TensorFlow was really big at the time. Containers were really big. I had a bunch of users who wanted to use TensorFlow with containers. I started experimenting with bind mounting libraries in from the host, and I found that I could make it work. And so I was talking with Greg Kurtzer, who was the guy who created Singularity out at Lawrence Berkeley National Lab. And I was like, hey, I think we can make this work if we bind mount these libraries in. And he was like, that's crazy. That's never going to work because you've got a glibc inside your container. And those libraries, there's no guarantee that they were compiled with that particular glibc. And so he said, let's reach out to NVIDIA. And so we started talking to a couple of folks who were working on containers at NVIDIA. And we asked them how their implementation was working. And it turned out it was basically that. And the reason it was that was because NVIDIA distributes their libraries as precompiled binaries, and they just make them real flexible so that they'll work with a lot of different glibcs. So you can sort of expect the ones that you get to work with a lot of different libraries. Yeah.
Right. I I mean, this is a pain point, right? So we're doing this. We were doing El Capitan, so we did a Singularity, and we were having to bind mount in, you know, like the Cray environment, so that we could get the MPI pieces we wanted and the ROCm pieces we wanted. And to make it all work, what we do is make the container image be the same OS as the base OS. That way our glibcs always match up correctly.
Yeah.
And
yeah, I don't know if the same guarantee holds for ROCm. So the community right now is kind of struggling to support AMD. We really need somebody, you know, we really need somebody at AMD to kind of like, you know, come along and help us out with that. Yeah.
I know there's one here, in here, and they use containers quite a lot in their testing.
Yeah.
I don't. It's an interesting topic, and I know it's a struggle, at least for us. So.
Yeah.
Thank you.
Yeah. So we talked about the making GPUs and devices available to Obtainer. Is that on the roadmap for Obtainer to support CDI?
Yeah. So we released in the pre-release last week.
So yeah, I think Dave is going to give a talk later about
What's new? And
and also maybe roadmap stuff. What's coming up? I don't know. Maybe not.
not roadmap, but
Okay.
what's new? Yeah.
All right. So I won't steal his thunder. Yeah.
Yeah.
Cool.